as you recall, we discovered the definition of the derivative. And of course, the derivative is the same as the slope, right? Or instantaneous rate. And that is the limit as h approaches 0 of f of x plus h minus f of x over h. That's our old-fashioned slope formula. Change of the y's over the change of the x. Remember, h represents the distance between my two x's. I'm finding the slope between 2 points. All right, so let's dive on in. I want to find the slope at x equals 2, so let's plug in x is 2. And h is something that's very, very close to 0. I'm just going to call it h for now. How are we doing? So far, so good?
Looks good.
All right, so now I have my actual function. F of x is defined to be x squared plus 4x. So f of 2 plus h, that means I'm going to plug in or substitute in 2 plus h for x. So it's 2 plus h, quantity squared, plus 4 times 2 plus h. Right? That's that first part. Minus f of 2. All right, I'm substituting in 2 for x, plus 4 times 2, all over h. Okay, time for some algebra. 2 plus h quantity squared. Well, that's 2 plus h times 2 plus h. So that's 4. You have to do your double distribution. Plus 2h, plus another 2h, plus h squared. All right, now here we're distributing there. Plus 8, plus 4h. Okay, I took care of this part. Minus, let's see, 2 squared is 4 plus 8 is 12, all over h. Okie dokie, let's come on up here. So this equals the limit. You have to keep writing equals the limit as h approaches 0 to remind ourselves that that's what we're doing. Well, let's combine like terms. Let's see, we have 4 plus 8 is 12. Minus 12, 0. I love that. Let's see. 2h plus 2h is 4h plus 4h is 8h. So I took care of my h's. Plus h squared all over h. What should I do next?
Factor out an h.
Let's factor out an h. If you guys remember in class, we discovered that there is a removable discontinuity. So let's factor out an h so I can remove that removable discontinuity. And away the h goes. So now I have the limit as h approaches 0 of 8 plus h. Hey, is it safe to plug that 0 in for h now? Sure is. Of course, I couldn't plug the 0 in here because I had 0 in the denominator, but now we no longer have 0 in the denominator. So I can safely plug in 0 for h. And there we go. There's my slope. The slope of my function at x equals 2 is 8. It's my instantaneous rate of change if I were talking about distance and time.